everybody talk about?
I'm not a singer. I like to sing. Do you guys like to sing?
Yeah.
It's fun to sing. Because your throat's an instrument, right? You guys have been learning about sound. Now, how does the string work?
It vibrates.
It vibrates, right, when you pluck it. But the little cups on the end, or do you need the cups to hear it?
Yeah.
You can't just hold the string and vibrate it and hear the sound, right? You need the cups.
Yeah.
That's because they're hollow. Hollow things are needed to make instruments, and that's because of the nature of sound waves. Did you guys learn about sound waves?
Yeah.
Yeah, what have you learned?
If the sound wave's long, it's I think it's a low note, but if it's hot,
If it's stretched out, if the sound wave's stretched out, it's a low note. That's a good thing. Yes, that's true. What if it's short? What if it's really tight, the sound wave?
It's a fast.
It's really taut and it goes quick.
It's a fast one.
It's fast and
It's high.
it's high, right? So sound waves are just like ocean waves. Did you guys talk about that?
No.
You know how when you get in the ocean and the waves come and the water moves up and then down? So there's a lot of water squeezed together here and then it crashes down and it spreads out, right? So does anybody know what the air is made of? Yes, Ivy?
Molecules.
Molecules. What are molecules? Anybody? So you know how you can tell that there are atoms in the air? If you go like this in front of your face. Do you feel the wind?
Yeah.
Yeah. If there were no atoms in the air, if we were in a vacuum, you wouldn't feel that wind. That wind is atoms hitting your face. That would be like if you were in the water and somebody was splashing you. Isn't that cool?
Yeah.
So when you talk, what you're doing, and when you make noises, if you clap your hands, even if you clap your hands near your face, you can feel the breeze, right? Those are big waves. Those are teeny tiny waves. Yes?
People always breathe in and breathe out.
That's true. So there's oxygen in the air, there's nitrogen in the air, carbon dioxide, a little bit of helium, and some other gases. But there are a lot of different kinds of molecules in the air, but primarily oxygen, water molecules, carbon dioxide, and nitrogen. When you clap, you make a lot of vibrations. And so what happens is you're pushing, you're making a wave, like making a wave in the ocean. When you clap, you're making a wave. If you clapped in the pool, underwater, you would make a wave. So when you clap in the air, you make a wave in the air. It's just not in the water. So these molecules, these atoms, they come together in dense areas where there's a lot of them in a small amount of space, and they spread out just like a wave. Just like if this were a wave in the ocean, this would be going like,
Sorry, they're better.
oh no, that's okay, like this, and then down, and then up, whether it be another area where the molecules are squeezed together, and down. And then they'd be far apart. So if I clap, here they're closer together if you can visualize that. Okay, so just like in a wave in the ocean, the water comes together, it all crowds together in the wave, and then when it comes down, it spreads out, right? Because if you stand under the wave, you can feel that water spreading out, right? It'll take you with it. It'll take you with it all the way to the shoreline, so you can body surf or surf on a surfboard or whatever. This is where the water molecules are really close together. Then when it crashes, that's where they're far apart. When the wave comes back up, if it's not crashing, you've seen the wave in the ocean go across like this, right? You see it kind of rolling over the water. That's exactly what a sound wave does. It rolls over the air. And so the areas where the molecules, every time I clap, I'm pushing the molecules in front of my hand together. Each time. Excuse me. So if I go, I'm actually making sound waves at a frequency as well. So each time I clap, I'm pushing the molecules together. So I'm making a wave like this. Now, you guys learned about the length of a sound wave, actually. So from here, all the way back to that part again.
Oh.
That is called a wavelength. In the ocean, you would call it a wavelength too, the length between the crests or the peaks or the high points or the dense areas of the wave. So when you have a short wavelength, you guys have found out that that makes what kind of sound? What does it do to the sound wave when the wavelength is really short? That would mean it goes like this. Okay, let me do a short wavelength and then we'll do a long wavelength. Okay, of these sound waves. So when you have a long wavelength or thing related to sound, long, what kind of large, long, what kind of sound, what does that do to the sound? Yes,
It
Lily?
makes it low.
It makes it low, that's right. So long things related to sound, low sound, right? It affects the pitch. We call that the pitch of the sound, whether it's high or whether it's low, right? If you have a really short wavelength, the wave would look like this. And what kind of sound would that make? Yes, Sam?
It would make a high pitch.
A high pitch. That's right. So the length of the wave is related to the pitch, but the height of the wave, how high it gets, does anyone know what that's related to? Ivan, do you know? If a wave is higher, what does that do to the sound? If it's bigger, it'd be like having a huge tsunami
It makes it
in the ocean.
it makes it louder.
It makes it louder, that's right. And that's called the amplitude of the wave, the height of the wave. The bigger it is, the louder it is. So if I had a wave like this, to call that number 1, and another wave like this, and that's number 2. Which one's going to be louder, number 1 or number 2?
2.
You can yell that out. Yeah, 2, right? Very good, very good. So the other thing that you need to generate sound waves, I'll leave this up a little bit, to generate sound waves that are loud enough for our little eardrum to hear. And that's the other thing, the eardrum really is like a drum. What happens is these areas of dense particles, when they hit your ear, it's just like taking
It bounces back.
it's just like taking a mallet and hitting a drum. This is what the sound wave's doing. Okay, and then if you want to, if it were a high frequency sound, it would be like this. And your brain interprets those different frequencies as different sounds.